Good morning, students. So, am I audible now? Okay, thank you. So, okay, see, today's session will be just revising your chapter number 2. Okay, since we have a weekly test tomorrow based on unit test, based on unit 2. So, we'll be just go through overall um, important points, or will be highlighting the topics no from unit number 2. Okay, so first we'll start with 8086. So you need to start with a pin diagram or of 8086, or we call it as pin signal description. Okay, what it may be. So first, no, you first thing is you should be thorough with the what pin IC pin numbers. Okay, so you should know each what in each pin. So you all know that it's 8086 is an 40 pin dual Indian package IC, and all the pins are TTL compatible. Okay, so apart from this, you should also be able to remember what are the pins available in all the 40 pins. Okay, so you should be able to know the pin diagram. Okay, so starting from pin number 1 to pin number 40, so you should know what is the function of each and every pin, and where in which pin it is located. Okay, sometimes they may even ask like that also. Okay, well, so if your final semester exam is going to be MCQ, means you may expect questions like that. Okay, so normally, no, in pin diagram of 8086, as I said, it's a 40 pin dual Indian package, and all the pins are what TTL compatible. So, and then no, you people know that what 8086 works in two different modes. So minimum mode and maximum mode, and this minimum. So the mode operation usually depends upon your pin number 33. So we call it as MN/MX bar. So whenever the spin is going to be high, it works in minimum mode, and whenever the spin is going to be low, it is going to be what work in maximum mode. So for high, I'll going to connect it to what plus VCC 5 volt, and it is for low means I'm going to connect it to what pin number 33 is going to be connected to ground. Okay, so which means based on this pin only, rest of the mode operation is going to be selected. So you have to remember this pin number 33, especially specific pins. And apart from this, you should also know that what the pin signals from 24 to 31. Okay, so they'll be different for minimum mode of operation as well as what maximum mode of operation. I think you can see from the diagram itself. From 24 to 34, we have two different signal pins, which means one shows for your minimum mode, other one is going to be for maximum mode. And signals assigned to all other pins are going to be common for both minimum and maximum mode of configurations. Okay, so first we'll see see here, I'm not going to discuss in detail, just we'll see a overview, because no, we have to cover all the topics from unit 2. So we will be just seeing an overview. So what are points which I'm going to highlight, please make a note of it. Okay, so first we'll go through go through a fast touch up with the common signals available. So AD0 to AD15. So these are going to be what address bar data, which means they are multiplexed pins. So they performs both address and data operations, and they're going to be what bidirectional and tri-state type. Okay, and apart from this, data bus is 16 bits. So all the 16 bits we have covered. But what about address bits? 20 bits. So we have covered only 16, and rest 4 are going to be what A16 to A19. And this A16 to A19 is also a multiplexed pins with what signal status pins S3 to S6. So A19 bar S6 to what A16 bar S3. So these are we call it as what multiplexed pins. It performs again dual functions. One is going to be a higher order address bus, and then a status bus. So again, it's going to be output type of pins. Okay, and BHE bar slash S7 high enable. Okay, I think you can expect a question from this type of pins. BHE bar bus high enable. Again, it's an output pin. Status pin as usual. Okay, and minimum maximum dashnam is also, it is a mode control pin. We call it as what mode control pin, and this is an input type of pin. Read control, RD bar read control. Okay, and test. So which means what wait on test control. So again, it's going to be input type of pin. And ready. So ready means what wait state control pin. So again, it's going to be input. So system reset pin, and we have two interrupt pins. One is going to be NMI, non-maskable interrupt request, and INTR, interrupt request. Both are going to be input type of pins. Clock, we have a clock input type again, for mainly for provides what clock frequency of for system clock, acts as a system clock. And VCC and ground power supply pins +5 volt and 0 volt. So one is going to be input power supply, there's ground power supply. Okay, so all these are common mode pins. Okay, see, just please go through the function of each and every pin, especially BHE bar, read bar, test bar, read, ready, reset. These type of pins you should know what is the function of these type of pins. And moving on to minimum mode signals. So I think pin number 24 to 31 you can refer. So we have hold request. So it's hold request, hold acknowledgement, HLDA, write control, and M bar, M/IO bar. So which means what? Memory or IO device. So it's going to be memory bar, IO control type output pin actually. And DT/R bar, data transmit or receive. Okay, so again, it's an output type of pin. I think almost so. See, all the pins from 2431 in minimum mode are output pins except your hold. So hold request alone is act as an input pin, and rest all everything is going to be what? Output pins. Okay, and ALE address latch enable, data enable, DEN, and INT interrupt acknowledgement. So we have these pins. Okay, and moving on to maximum mode signals. So whenever you're going to connect it to ground, so logic low, obviously what 8086 will work in maximum mode. So we have only few signals here. So we have just bus cycle status S2 bar, S1 bar, S0 bar. So this we call it as what? Bus cycle status. So I think there is a tableau column. Okay, so which means what does these status signals do during various machine cycles? Okay, so just please be thorough with that conditions of operations. For example, no. If all the three pins are going to be 0, like S2 bar 0, S1 bar 0, S0 bar 0 means what? So what type of machine cycle it is? Interrupt acknowledge. Okay. Suppose if it is going to be 101, S2, I'm taking this order. S2, S2 bar, S1 bar, S0 bar. If it is going to be 101, so which means what? I think read memory. Similarly, 110 means write memory. So what machine cycle it performs? So those, no, it will be available in your tableau column. Please have a look at it. So you may also expect questions from that. And apart from, we have what RQ bar GT1 and RQ bar GT0 request grant. Okay, so these type of signals also are available. Okay, so what is the function of these things? So these requests are used by other local bus masters for the. Okay, so to force your so purpose of these pins, nothing but it forces the processor to release the local bus once the processor ends the current bus cycle operation, so that others can make use of it. And as usual, these pins are going to be bidirectional. So since we have two request for grant signals, when there is any situation that both there is a request from both the cases, your request on GT0 will have higher priority when compared to what? GT1. Okay, so based on priority only, the corresponding local bus master will be allocated. Okay, this is the function of your request bar grant. So status signals just now we saw. So mainly it is used by what? Status signals, it is mainly used by 8288 bus controller. I think, hope you remember, maximum mode we have a bus controller to take care of all these control bus control signals, and it's manufactured by Intel 8288 bus controller. So it will take care of controller to generate what? Corresponding bus timing and your control signals. Okay, and then moving on to lock. So what is the function of lock? So it is mainly used as what? So bus priority lock control, you call it as, okay, bus priority lock control. Okay, so it is an actually output signal. So usually, this at least it is activated by a lock prefix instruction, and it will remains active until the completion of an instruction prefixed by lock. Okay, so for that purpose we use this lock. So normally, this 8280, it provides bus system, personally use what lock. I have let's say QS1, QS0. go since we have different pins, we will be four. This goes with mean relation. And one from the queue is going to be fetched. Okay, so it provides the status of the queue on these lines. For that purpose, we use this queue status. Okay. Okay, so please I repeat, just be thorough with the Tableau column or working conditions for different combinations for queue status as well as your status signals. So you can take on this part. Okay. So apart from this, I think hope you know functions of these minimum mode signals. Okay, that you can just go through it, and then. So whatever we said, it will be discussed in detail here. And even you should be thorough with this Tableau column, that S3 and S4. No, we have, as I said, we have status signals S3 and S4. Okay, so so these status signals, no, is used to what indicate which segment is accessed during the current bus cycle. So for that purpose, we use the signal spot status signal S3 and S4. So depending upon the values, the corresponding what segment register will be selected. So I repeat, so you should be thorough with this Tableau. So totally, I have said we have 3 Tableau columns so far. So all the 3 Tableau columns you should be familiar with. So they can ask you any questions from this. So this is another Tableau column which I said. So as I said, no, 110 means what? Write memory. 100 means memory read. So similar to that. And this is another Tableau column. So please go through all these 3 Tableau columns. Okay. And then we move on to another topic called basic configurations. Okay, so as we all know that what we have 2 different configurations or modes available in 8086. One is going to be minimum mode, other one is going to be maximum mode. Okay, so minimum mode means only one CPU will be there. So smaller systems. Maximum mode will be having what many number of more than one CPU will be available. And it will be used in what large systems. So we call it as what maximum mode configuration. Okay. So first we'll see minimum mode configuration. Okay, fine. And this is a typical diagram. Okay, a schematic diagram of a minimum mode configuration. Okay, so as you all know that what. So what are the components available? So as I said previously, in minimum mode, we'll be having only one CPU, one processor. Okay, so which means the processor itself will generate all the required bus control signals. Okay, and there is no need for what any external bus controller here in minimum mode. Okay, so maximum mode is the opposite. Okay, so which means that since they'll be having many processors, obviously no, they need an external device to control, take care of all these bus control signals. So the device used for the purpose we call it as what? 8288 Intel 8288 bus controller. See, also no, you should be familiar with the IC numbers. Okay, for example, in both the configurations we have a clock generator. So the clock generator IC, do you remember? So you may also expect questions like that. Okay, so should be familiar with the IC numbers. Okay, for example, 8086. Okay, leave it. A co-processor, IO processor, and this clock generator, bus controller. So all these type of devices you should you should know actually. So we have a clock generator. So the clock generator is specifically designed for what? 8086 is what? Intel 8284A. So this is the clock. Okay, so as you know that what here also we have, so already it's mentioned there. See, clock 8284 clock generator. So this clock now generates clock signal, ready signal, and also what reset signal required for what 8086 processor. Okay, as I said previously, it generates a TTL level peripheral clock signal. So that we can also use it for what other peripheral devices available. Okay, and regarding this 8284, no, it is an 18-pin IC package. You can make a note of it. It's an 18-pin IC package. Again, dual inline package. DIP. Okay. So What are the pins available? Do you have any idea? Okay, so I'll just recollect what are the pins available in 80. So we'll be having, so just to go through the pins also, we'll be having a clock synchronization pin, a peripheral clock pin. We'll be having address enables AEN1, AEN2. We'll be having a ready 1, ready 2, bus ready. Actually, I think we'll be having clock signal, ground, VCC, and then we have two pins here for to connect your crystal. No, we'll be having two pins, X1 and X2. So usually called as pins for crystal connection, and we have EFI, so which means external frequency input option, or OSC, oscillator output, and then yeah, fine. I think reset and RES. Okay, so reset means it is going to be reset signal to what 8086. Okay, and we have something called RES bar, which means what it is going to act as reset input to what 8284. Okay, so there's a difference between reset and RES bar. Okay, okay. So these are the pins usually available. Okay, so the main, as I repeat, the clock generator here, it is used to what generating for clock signals and reset signals. Okay, so okay, fine. So and apart from this device, no, apart from this clock generator, we have another important device which is commonly used as a bus controller. Okay, so though this bus controllers will not be available in 8 minimum mode, so this will be specifically designed for use in what maximum mode. Okay, so the Intel 8288, so it is specifically designed IC for 8086 microprocessor. So in the purpose of this what it is, you generate your bus control signals. Okay, so it basically reads the status signals from the processor and correspondingly generates what bus control signals for either to your memory or your what IO devices. Okay, and as I said, Intel 8288 is going to be a 20 pin IC package, again dual inline package format only. So remember, so far we have seen 3 ICs and the pin numbers 8086 40 pin DIP package, and 8284 is going to be 18 pin DIP, and 8288 bus control is going to be what 20 pin DIP package. Okay, okay. So apart from this, and here I want to just mention how demultiplexing of address and data in an 8086 system bus happens. Okay, any idea you have? So how demultiplexing takes place? So which signal helps to demultiplex the address or data pins? Okay, fine. So normally, to demultiplex the address or data bus, okay, for the processor, has a signal called ALE, address latch enable. So usually it will be asserted high. So and then low by the processor, normally at the beginning of every clock cycle. So every bus cycle. So at the same time, simultaneously what happens means the address will be given out through AD0 to AD15 lines, as well as A16 to A19 lines. Okay, so in addition to this, demultiplexing address lines and address bar data and address bar status lines, it is also possible with the help of 8-bit D-latch. So I think here it is there. So I think you can see here 8-bit D-latch, address latch, something is given now. So 8-bit D-latch. So here I am going to use what 87 as D-latch means, I think flip D-latch number 74 LS 373. Okay, so there's an 8-bit D-latch available. So which means the AL, it will be connected to your enable input of this external 8-bit latches. So whenever this AL is asserted high and then what low, the addresses will be correspondingly be latched into what output lines of the latch. Okay, so until then it holds the what until the next bus cycle it holds the address. Okay, so after latching the address, what happens? The AD lines, the AD0 to AD15 lines will be free for data transfer, and remaining A16 to A19, they'll be free for what carrying your status information. So because there's a multiplex, so once the address process is over, they'll be used for what data as well as what status pins respectively. Okay, so normally the first T cycle. So as I said, Subhash ma'am once I think ma'am discussed about the machine cycles and all. So the first T state of every bus cycle will be used for what? Address latching in 8086, and the remaining T states what will be used for reading or writing operations. Okay, and apart from this, 8086 also provides what? Two controller signals, DT slash R bar and DEN bar. So mainly these are used to what? So DT, data transmit or receive, which means what? It is used to decide the direction of data flow. Okay. So from where data is going to be either transferred or it's going to be received. So it decides the direction of data flow. And DEN bar, again, it is used to enable the data buffer. For that purpose, we use what? This. Okay. Okay. So in minimum mode, these points will be sufficient. Okay. Just so transceivers, there is going to be a data buffers. Okay. So moving on to maximum mode configuration. So here it's clearly see. So all the signal pins and its function is being discussed clearly. So in case of a maximum mode, what we need so same. If you look at the block diagram, no, almost 75% will be similar to your minimum mode only. The only difference here we have is your what additionally will be having an external bus controller 8288. Okay, so we should employ this 8288 to generate your bus control signals. Okay, so okay, so and then so what is the difference is going to be there here? Any difference on the? So if you notice, this means this 8288, no, you can configure for multi-purpose modes of operation with the help of signals AEN bar. We have something called AEN bar, IOB, and CEN. So with the help of these signals, no, you can able to what configure even for uniprocessor mode configuration also. Okay. So normally the bus controller can be configured for uniprocessor mode of operation by just simply what grounding your AEN bar signal and IOB. Okay. So and then you have to apply what plus 5 volt to your CEN. In case if it is going to be a multiprocessor mode of operation, no, then IOB should be connected to plus 5 volt, and the signals AEN bar and CEN, no, they should be what supplied by a what 82. We have something called bus arbiter, such as for example, there is a specific IC available from Intel 8289. Okay, you can just make a note of it, 8289. Okay, and as usual, no, so data bus node will be provided with some data transceivers. Here we are going to use what two bidirectional buffers. So 74 LS245. So we are going to use it as what data transceivers. Okay, and apart from this, no, rest everything is going to be same. So minimum mode and maximum mode configurations. So again, the same tableau column has been discussed here. So difference between minimum mode, maximum mode. Okay, fine. As you can have a look at it. No issues. And then you'll be having timing diagram. So timing diagram also you may expect 1 or 2 questions. So you should be thorough with it. So normally, the bus cycles will be classified as what memory read cycle. Usually it requires what 40 cycles. Okay, and memory write cycle again it also requires 40 cycles. IO read cycle again it requires 40 states. IO write cycle 40 states. And in addition to this, we have what interrupt technology cycle, which alone requires what minimum of 8 T states. Okay. So what is my T state? If they ask you what is my T state, what are you going to define? So normally, no, the processor it will take some time to perform a bus cycle. Okay. So the time taken to perform a bus cycle only is specified in terms of what your T states. Okay. So in case of your 8086 processor, no, time duration of 1 T state is equal to what? 1 time period of your internal clock of your processor. Okay. So I think what is the clock duty cycle of your 8086? Hope you remember in unit number 1, 33%. Okay. So normally, no, the T state it starts in the middle of the falling edge of your clock signals. So there is some reasons behind why you're going to go for such an options. And apart from this, timing diagrams are available. So for minimum mode and maximum mode, again for minimum mode for read cycle, write cycle, maximum also read and write. So So what is the purpose of timing diagram? So the timing diagram, it provides what information about your various conditions, whether it's of the signals when a bus cycle is being executed. So various conditions in the sense whether your signal is in high state or low state or high impedance state. So like okay. So normally, this type is if you just look at the data sheets of 8086, the timing diagrams usually it will be provided by the manufacturer itself. Okay. So here they are given with 4 different timing cycles. I repeat, for minimum and maximum mode, as well as for what both reach cycle as well as what write cycles. You need to just go through it. So that's what I said. No, so memory read, memory write, IO read, IO write, and bus idle states. So each one will be discussed here. Okay. So just go look at the timing diagram. So if issues or any doubts in the diagram, if we speak, ask us. Okay. Then we move to some new concept called IO programming. Okay. So IO programs input output programming. So for programming any IO any okay. Normally data transfer schemes means what does it mean? Data transfer means what? Data transfer your what? Peripheral devices. Okay. So normally in any if you take any microcomputer, no. So data transfer takes place between two devices in a say, which means what? It may be between microprocessor and memory, or microprocessor and IO device, and memory and IO devices like such that. Okay. So here also no. So for effective data transfer between these devices, no, the timing parameters of the device should be matched. Then only you can able to what transfer it effectively. Okay. Because no, for example, let me say one example. Suppose suppose constant IO device, say assume that it's slower in operation than the processor. So what happens at that time? So it means what? So when compared to a processor, IO device works slower. So what will happen at that time? So it may not be able to send the data to the processor in the expected time. Okay. So such situations will be arise. Okay, normally. So that here for that purpose we go for this IO programming. So normally, as I said previously, data transfer schemes you can broadly classify into 3 categories: programmed IO, interrupt driven IO, and DMA. Okay. So in programmed IO again we can classify into 2 types. We call it a standard IO or what isolated IO, something we have another name, or and memory mapped IO. So again programmed IO is again further classified in 2 types: standard IO and what memory mapped IO. And interrupt driven IO again it is classified into 2 types: external interrupts and internal interrupts. External interrupts only we have this maskable and non-maskable. Okay, and under internal interrupts we have again internal interrupt due to what exceptional conditions, and software interrupts. So all these are classification under internal. And then we have DMA. So DMA also, as I said, we have 3 different types available. So one is going to be block transfer DMA, cycle stealing DMA, and demand transfer DMA. Okay, so we have this classification overall view of your IO programming. Okay, so please be thorough with this also. Okay. So now we'll see one by one in detail. Okay, not in detail, in just the overview, because we have to complete. So in case of your programmed IO data transfer, what does it mean? Programmed IO data transfer. So normally a memory resident routine. So it usually requests the device for data transfer, maybe to or from any processor register. So normally this program and IO data transfer scheme is used whenever there is any relatively a small amount of data out to be transferred, we go for programmed IO transfer. Okay. So usually 1 byte or 1 word of data can be transferred at a time. Okay, examples. So can you state some examples where this programmed data transfer can be used? Like as I said, 1 byte or 1 word, like 8 bit or 16 bits means what? ADC, DAC, your 7 segment LEDs. Okay, hex keyboard. So these are a few examples of this or programmed. It uses this programmed IO data transfer. So again, programmed data transfer scheme. It can so it can also further classify into what synchronous data transfer scheme and asynchronous. Okay, so synchronous data transfer scheme is going to be the simplest when compared for all the other data transfer schemes. So what does here it happens means so normally in this synchronous, in case of a synchronous data transfer, the processor does not check for the readiness of the device. So directly the IO device or peripheral what it may should have what match timing parameters. If it is so, obviously what the processor does not check the readiness of the device. Okay, so whenever data to be obtained from your device or transferred to the device, so the user program can issue an simple instruction at the device. So what happens at the end of this instruction execution is the transfer would be completed. Okay, so this is a simple type. As I said, it's the simplest of all what data transfer devices. And also, in case of this synchronous data transfer, you can also implement with a small delay. Okay, after the request has been made, you can introduce some small delays. Okay, this is also an option. For example, this mode 0 input output. In case of 8255 is an example of what simple synchronous data transfer scheme. I repeat, mode 0 input output of 8255 is an example of what synchronous data transfer scheme. And asynchronous mean asynchronous data transfer. So normally when the speeds of the processor IO does not match, then we go for what this method. Okay. So in this scheme, what happens when the processor it will simply send a request to the device for read-write operation. So then after sending a signal, the processor keeps on polling the status of the device. So once it is ready, once the device is ready, means the processor executes a data transfer instruction to complete the process. Okay. So this is the process that takes place in asynchronous. And example for this asynchronous type is your, I think 8255. You remember unit number 3. So the mode 1 and mode 2 handshaking signals, handshaking data transfer of 8255. So without interrupts. So those is the best example for what asynchronous data transfer. Okay. So please remember all these examples can be asked. Okay, in your MCQs. And then moving on to interrupt driven, IO driven. So I'll just make it short. So the interrupt driven is so of all the 3 methods that we have, the interrupt driven is going to be the best method of data transfer. Okay, because in terms of what means efficient utilization of your processor time. Okay, so in this scheme, the processor first initiates the IO device for data transfer. First is it initiates the IO device for data transfer. So second step after initiating the device, the processor will continue the execution of the instruction in the program. Okay, so third step, what is does means once after the end of this instruction, every instruction, the processor will check for any valid interrupt signal. So suppose if there is no interrupt, the processor will continue the execution. Okay, so there is a simple process that takes place in a interrupt driven IO scheme. Okay, and moving on to DMA. So DMA. So DMA is used for what? Large block of data transfer between your IO device and memory. Okay, so examples for DMA, I can state what your CRT controller, floppy disk, hard disk, high speed printer lines. All these are a few examples of your DMA controller. Okay, and then so again, as I said, we have 3 different types. Just go to the single stealing DMA, also called as what single transfer mode DMA. We have block or burst mode DMA and demand transfer mode. So just to go, what is function of these 3 DMAs? Okay. So multiprogramming. So apart from this, we have multiprogramming also. So in addition, now we have something called multiprogramming concept. So hope you know what is multiprogramming concept. So just know what is the difference between uniprogramming and multiprogramming. So when suppose when various tasks in a program, they are executed simultaneously or concurrently. So the method of execution we call it as what? Multiprogramming. Okay. So know the advantages of this multiprogramming. So a few advantages could be what? Your processor idle time can be minimized. So memory management can be used efficiently. Okay, so multi-processing is allowed. So it also allows what? Multi-users at a time. So these are the few advantages. just go through the advantages of this multi-programming. And then the final topic, we had two more topics, multi-processor configurations. So multi-processor means that we'll be having two or more processors that execute instructions simultaneously. So those situations we call it as what, multi-processor configurations. Okay. So normally, the extra or added process, it can be a special purpose process. Okay. So which may be specifically designed to perform certain tasks efficiently, or it can also be or simply a general purpose processor also. Okay. For example, so we have a multi-processor system can be formed by using 8086 processor and an 8087 co-processor. Okay. So what is the purpose of this co-processor? It's called 8087. So the co-processor usually called as what? Math co-processor or numeric data processor, NDP. Okay. So this processor, this co-processor, it is specifically designed to work in parallel with your 8086 processor, and mainly it is used for mainly this processor it is specifically designed to take care of all the mathematical calculations. So like integer, floating points, so those type of mathematical complex calculations also could be taken care of this 8087 Intel 8087 co-processor. Okay. So it is used in combination with 8086 in maximum mode. So again, it's a 40 pin dual pip package. So okay, so you just go through that pin configuration of 8087 as well as your 8089 IO processor. Okay. So apart from that, we have closely coupled, loosely coupled multiprocessor configurations. We have different types: co-processor, closely coupled, and loosely coupled configuration. So you just know the architecture of this closely coupled and loosely coupled architecture. Also the advantages, merits, and demerits of both the configurations. Okay. So how does a closely coupled look like, and how does a normal loosely coupled look like? Okay. And so I think we have only 3 more minutes. Okay. So in addition to this, we have last topic, introduction to advanced processors. So where we discussed 80, 186, 286, 386, and 486. So it will be better if you just go to the comparison chart. That will be enough. So just take a comparison chart and just be thorough with what is the data bus, external data bus, internal data bus, address bus, those values, what is the physical memory size or clock frequency. So those things you can just remember, because it may be asked. And apart from that, what are the new features that has been added? For example, let me see. For example, what to say? So I think when we discussed about this advanced process, so cache memory, is it something cache memory? This cache memory concept, it is actually introduced only in 486 process that doing DX version. I hope you remember, I guess. So similarly, the superscalar architecture, we discussed something called superscalar architecture. So that concept, that new feature has been introduced only in Pentium 586 processor. Okay. So we have certain new features been added in each processor. Okay, for example, this 8086, suppose if I ask you what is the new feature added in 8086, means I can say that it's a pipeline architecture, instruction queue, so segmented memory. So all these are being introduced initially in 8086 only. Okay. Suppose if I ask you what is the new feature added in 386. So do you have any idea? So 386, it starts with 32-bit processor. It's the first 32-bit internal registers. And we have breakpoint instruction available in 80386. So like that. So each one will have separate or new unique feature being added. In 286, I think we have multitasking possible, memory protection is possible, virtual memory is possible. So all this like that. So just go through the features that has been added in 80, 186, 286, 386, and 486. Okay. Okay, so almost I have we have discussed some basic points, the important points that will be used for your tomorrow's test. Okay, so whatever I have stated, okay, just go through those topics in detail. You can able to do the exam well. So if you have any doubts, you can just raise your questions.